lecture starting with chapter 10, classes and object-oriented programming. Let me share my screen and get to my repo, and then we can get started. So I'm sharing my screen, and if you go to my repo and you look for my user handle, that's at Suchiroda, you can see all the repos, and then I'm going to fork that repo. And chapter 10, classes and OOP, is the one that I'm going to fork. And I'll keep the same name. I'm going to fork it. So here we go. So I'm going to move my tutorial to this side just so I have more space for coding. Today I'm using a lighter theme just to mix things up. Okay. So here we go. We're going to talk about object-oriented programming. So we've already talked about the procedural programming style and object-oriented programming style. Procedure is when we use functions. So that's all we've done so far. Up until now, all we did was we created some variables and we passed them to some functions as arguments, and the functions return some data back, so on and so forth. But the problem was the data and the functions were disassociated. There was no connection. So another programming style is object-oriented programming style. In this style, the data and the methods are kind of tied together or encapsulated together, and this is called encapsulation. So you can make your programming to a point where certain data types or certain functions cannot be used by certain kinds of data. So we have seen that in dictionaries and lists. And so if you want to use an append method, you can only use it on a list. You cannot use it on a dictionary. Or if you want to use a method like isAlnum, that you can use only on a string. Try using that on a dictionary and see what happens. It doesn't. So how is Python making that kind of distinction? That is when you're binding the data and the methods that operate on the data together. So here, the only difference here versus here in object-oriented programming, the data that we used to call variables before, now we just call them attributes. And what we used to call functions before, we call them methods now, because they are all inside one big container called a class. So the overview of this class is going to be, I'm going to talk about the different types of attributes. One classification is the class attributes and method attributes. Another classification is private attributes, protected attributes, and public attributes. And same story with methods. I'll teach you what private methods are, protected methods are, public methods are, and the other classification is accessor methods, or we call them get methods, and mutator methods, we also call them set methods. So this is kind of the overview for this whole chapter. So now let's get started and see. So procedures are basically functions that perform a specific task, and procedures operate on data items that are separate from the procedures. So as the program becomes bigger and bigger, the programmer really cannot keep track of what function should operate on what kind of data type. So a good example of procedural programming languages are, back in the day we had BASIC, and then C is also a procedural language. Object-oriented, however, treats everything as an object. So object is a software entity where it contains both data attributes and procedures together. So this binding is called an encapsulation. We see that. And to create an object, we have to first create a class. So basically, like if you want to build a house, you want to create a blueprint of the house. So basically an object is a house and a class is like a blueprint of how you want it to look like. So for example, if CINS 3002 is a class, then every single student that takes this class is an object. Or the homework assignments that I give to you, the paper printed assignments I give to you, the blank ones, each of them, think of each of them as a class because they are a template. When you fill out your answers and give it back to me, now each of that is an object. So That's kind of a very layman example, but object-oriented programming language examples would be Java. There's VC++, but lately there are some programming languages, or a lot of programming languages allow you to use both methods, like Python or PHP or Ruby, and many other programming languages let you choose. Hey, you want to do procedural? Sure, we'll allow that. You prefer object-oriented? Sure, we'll let you do that. You want to use a combination of both? Sure, we'll let you do that. So Python is a really good example where we can use both procedural and object-oriented at the same time. So let's see what classes and objects are, or how to define a class and an object in Python. So as we've seen, class is a description of objects' characteristics. So an object can be described both by its characteristics, as in its attributes, and also by its behavior that we can define through methods. So an object is an instance of class. So any object that inherits all these characteristics from the class is an object of that class. So to create a class, we have to write a class definition. And a class definition is a set of statements that define a class's data attributes and methods. So we're going to start writing the skeletal code and add more data attributes and methods to see how we can write our own class. So far, all the built-in data structures that we've seen, like dictionary, lists, and strings, they are all their own classes, and they all have their own methods that we've been using to manipulate. Now we are delving into writing our own data types, if you will, custom data types of how we want it to behave. So for example, if I want to define a student and also give the student some behavior, then I would create a class called class student. So the way to define a class definition is using the class keyword. So for defining methods, we have used the def keyword, but for class, we have to use the class keyword, and we have to give it a name, and then we have to open close parentheses and colon. So the only difference between the function definition that we've done so far versus a class definition is simply the keyword is class now. But also, good coding convention is to start class name with uppercase character. It's a good coding convention, but you don't have to. But I am going to recommend that for our class. So if you want to define a class called student, I would prefer it if you did it with an uppercase S. So that's it, as simple as that. We have defined an empty class. Right now it does nothing, but it's a shell of a class. So we've used the pass. So now we've created a class. How can I create an object of this class? So this has to be outside the class definition. So outside the class definition would be at 0 indent right here. And I'm going to just simply create an object name. The syntax is object name is equal to class name, open close parentheses. So if I want to call student1 is my object. If that is my object, all I simply do is use the class name, open close parentheses, and that's it. So just the same way as we have defined the function, we've also called it here. To be able to access anything inside the class that we're about to write, we have to have an object. So creation of an object almost looks like a function call, except for this is a class now. So that's it. We've created our first class and our first object. So I have a couple of try-me's for you to create a class called book and to create an object of that book. I want you to try it and see if that works. If not, the answer is provided for you. So, all right, so now we have a class. Let's start adding some attributes to it. Attributes are simply variables. That's all. It's a fancy name for variables when they are inside a class. Attributes are two types of attributes. Again, one classification is class attributes and method attributes. So let's create a class attribute. So what is a class attribute? It's think of a class attribute as a global variable. So remember when you used your file name is equal to books.csv, or file name is equal to students.csv in your projects, and that file name was accessible to every single function in your code, and that's a global variable. So think of class attribute as something like that. It is available to anybody in this class. So if I want to define a public class attribute, so now we're looking into another type of classification, which is public protected, and private. If you don't remember, refer to the very first image that we've seen in our tutorial. So if I want to do it, it will be in the first indent position. So class definition will always be at the 0 indent position. That means there will not be any spaces or gaps or anything. It'll be at the 0 indent position, and class attribute will always be outside any function definitions, and it'll always be at indent number 1. So think of it like that. So I have just created a class attribute called college, and I'm calling it ULM. I'm doing that because, no matter how many students are there, all of them will have the college is always going to be ULM for all of them. So it makes sense to create a class attribute. Now, if I have to create variables or data characteristics that change from student to student, like for example, name. One student's name is John, another, so I cannot create a class attribute for that, but any common data attribute that is same for any object, then that I would create as a class attribute. So this is what I've done. So now that is only creating the class attribute. How can I access it? So I'm just going to go down here. I'm going to skip the order in the tutorial and I'm going to jump to accessing the class attributes. Just defining them inside the class is one part. We want to do the other one. So how do we access it? To access class attributes, we can use the object name or the class name. So let's see. Let's copy and see. So outside the class definition, once I've created this object, now anything inside this class is accessible to this object. So I can use the object's name dot college, and I'm going to print it. That's all, very simply. So as soon as object 1 is seen, it's going to say, oh, that belongs to student. So what's inside student? Oh, college is inside student. So, and the value is ULM. Or because it's a class attribute and it is same for all the objects, I can simply use the class name, which is student, all in uppercase, dot college. So both of these will return me ULM. Now, another kind of data attributes is going to be protected class attributes. So how do we create protected class attributes? We simply put an underscore in front of it. So this one is called a public class attribute because it has no leading characters, but underscore defines, lets a programmer know that, hey, this is a protected attribute inside a class. What is a protected attribute? Why is it so special? We will see that in the next chapter. But if I define protected attribute like this, then again, to access this, I would simply have to use its name, just like with the underscore, just like we did earlier. We've used the object name. Here we use the class name. We can do the same thing, and then if I try to run it, it's going to print ULM and comp sci. So that's all great. So I'm gonna, for now, because these are class attributes, I'm just going to use the class name. Okay, the last type of attribute is going to be private class attribute. So what is a private class attribute? Anytime you want to hide something from outside the class, you want to make something available only inside the class but not outside the class, we define it as a private attribute. So in this case, for whatever reason, I want to define my file name with 2 underscores, which means file name is hidden. And if I try to print file name from outside the class. So now I'm outside the class and I'm using the class name and say, hey class, you have a file name attribute. Can you please print that for me? Python is not going to say, nope, can't do that because it is hidden from outside world. So again, in the previous cases, not only can we access the student's college, we can also change student's college to something else, which again, it's not desirable, but it's a possibility. So very simply, instead of students, the attribute defined inside the class, I can use to change it outside the class. So all of this is inside the class. All of this outside is the outside the class. So if I try to print it now, it's going to print LSU. Of course, it's trying to print that too. So it'll tell me originally it was ULM, but now it's LSU because I modified it. So class attribute can be accessed. They can also be modified outside the class if it is public or protected. Private, however, there's really nothing you can do. You cannot, this right now is hidden, but we will see that later what is truly hidden. So let's see. So that's pretty much all about how to define public, protected, and private attributes and how to access them outside the class. So you really don't even need to create an object to be able to access a class attribute. You don't really even need to create an object. It'll work without the object. If you choose to use the object name, that'll still work too. So there's another scenario here that I want to use. So in the event that I wanted to use the object name, it'll still work. And also if I created another student, so let's say student, so student 1 is an object of this class. Student 2 also is the object of this class. So if I try to print college for both these objects, so I'm going to forget about college and department for now. I'm just going to use college. And for student 1, if I print college for student 1, if I print college for student 2, it's going to be the same ULM because it is a class attribute. So that's the distinctive characteristic of a class attribute, that no matter what object you use to print it, it will yield the same result. So all right, so that's done too. I'm going to hang on to my class definition. So there are some try this for you. So create a class attribute and set the value, so on and so forth. So try those. And one thing to remember is all the objects will have the same value for a given class attribute, and we have just seen that. So next up is init method. Now, when I say method is not the same as attribute. Attributes are variables, methods are functions. So basically, any function that you define inside a class is now called a method. That's it. That's the only difference. And init method in this case is a built-in Python initializer method. So this is a built-in method and we're not writing the code for it. So how do we do it? What is the syntax? The def underscore init underscore and open close parentheses, and inside that there is a self. Okay, so let's see that, and I'm going to break it down one at a time. So def underscore init underscore, that's not going to change. Also parentheses, that's not going to change. Self, that's not going to change. So if I have put these up less than greater than symbols, that means these are all optional. If you don't have these, that's okay, but the bare minimum you have to have is a self. So let's break it down one at a time and then see what they mean. Just like we've defined a function before, we use the def keyword. So basically what we're doing is we're defining a function, but it's inside a class. So all our functions that we wrote before were at 0 indent themselves, but all these methods now are going to be at 1, indent number 1, because the 0 indent is taken by the class definition. So by putting this inside the class definition, I'm telling that init method belongs to this student. That's all. So this is the name. And what's the specialty? We've just seen what happens when you do 2 underscores, right? Before an attribute, when you place 2 underscores, it was hidden from outside the world, outside the class. It doesn't even exist. So init also is a private method that is hidden from the class. And what is its job? Its job is to initialize values, and we will see what that means later on. But for now, I'm just going to print something here. So I'm going to say print, hello, I am in init method. That's all. I'm not going to do anything else yet. So remember how we created an object. If I want to create an object, I have to give it a name, and then equal to, and the name of the class, open close parentheses. That's it. I've just created an object of student. So initializer method runs whenever you create an object. The first thing that Python does is it looks if there's an init method, and as soon as it sees the init method, it will execute it. So that's the first method usually in any class, and there's no way to call it from outside the class other than to create an object. So this is the default. In Java, they call it a constructor, and in here we call it initializer. So initializer can be used to initialize some value values. So remember these parentheses, they have been empty so far. So if we want to pass something to Python, to our class and say, hey, not just a student, I'm giving you some data values for this student. I want the student to have a name. I want the student to have the major. Then we can pass them in these parentheses. But before we can even go there, let me talk about self. So self is a very special parameter that you will see in any object-oriented programming. Self in here is mandatory. So any method you create inside this class or any class, the first parameter will always be self. Okay, so that is mandatory. Even if it's got nothing here, it will still have at least a self. So for example, hypothetically, if I want to create another method and I'm going to call it Suchi just for kicks and giggles, and then I can say pass, but because this is a class method, it cannot be just empty. It has to have self as the first parameter. So rule of thumb, remember that part. So anyway, so coming back to here, now I have, just by creating this student object, I have triggered the init method. So if I want to pass some arguments, some variables to student and say, hey, the student's name is, or if it makes sense like this, let's do it like this. Name and major. And I'm saying name is equal to John. And later on, we might put some input statements there and get the user to give those values. But right now, I'm going to just hard code them. So I have a student named John, and I have a major for him, which is computer science. So can you please create an object with that? So when the initializer method is called, right now, it's not accepting any parameters, even though we see one, but it needs to accept the name and the major. And then what initializer does is it attaches these variables to what's called self. So again, remember the self is the object's instance. So any object, so if you create student 1, then self in this case would have all the attributes of student 1. When you create student 2 with a different set of attributes inside the class, self will hold their values at that point of time. So very simply, I can create major here. So now initializer is taking these arguments from when I was creating the object, and it is now binding it to self. So now if there's a way to print self, we will see all of these values being printed. So that's about how to define an initializer method. So right now I'm not doing anything, but if I can print self underscore name here, and print self underscore major, then as soon as I create the student object, it will call the init function. The first statement is print. It's going to print that. The second two statements are binding the name and the major to the self.name. Again, this can be self.n or self.anything. I'm just going to keep it consistent. And then I'm trying to print those variables here. So the two print statements will print John and computer science. So let's see. So there you go. Hello, I'm in init method. And inside the init method, because these are attached to self now, so I can reference self.name, self.major. Also, the beauty of things here is you can access these from outside the class because you've just created the student 1 as an object. If I simply say student.1 name and I say print it, and then if I run it, it's going to print the student's name because name is attached to self. So when I do student1.name, it is initializing, it is calling, this one is calling the init method, and the init method is attaching name to self.name. So in this case, student1.name is what it's printing here. So if I create another student, say student2 equal to student, and then I'm going to say here, I'm going to hard code and say Mia and history. And then now I say print student2.name. Then these are two different objects, but they all differ to the class definition, and say, okay, as soon as the object is created, now Mia is attached to self.name. And when I try to print student2.name, it's only going to print Mia's name. So that's how we keep our objects separated. So that's how init method and how to access and how to call the init method. So we've seen that init method is a private method, and that's why we cannot just call it by its name, but the way to call it is to create an object. So if I asked you, how do you call an init method? You should be able to say by creating a method. So in this case, I have created two public attributes because there's no leading underscores. So to simply make it a protected attribute, I can put one underscore, and then correspondingly outside, I can use one underscore to access those values. So if I run it, it's going to print in init method John. Again, init is called when the second object is created, and then the name is Mia now. So if I want to make it private, I can do that. But then guess what? I cannot access it from outside the class anymore because Python hides it from outside the class. So there we go. It has no attribute with that name. So all right, so that is the first built-in method in Python, which is init, which is a private method. Very similarly, we have another one called str. Okay, so now we're going to see the str method. So what is it is another private built-in method, and it is obviously, because it's a method, I'm telling you that it's a method. That means it is going to be inside, it's going to be defined inside the class. What does it do? It returns the state of the object. What does it mean by the state of the object? It means it returns any and all the attributes bound to self in a string format, and we can format this string in any way we choose. So to be able to define an str method, we simply do that. So underscore str, that's going to be common. It's no negotiation there. It's a built-in method. So you have to use that name, underscore str underscore. And then remember, every method inside a class, the first parameter will always be self. And then it returns a string. What is it returning? It's returning a formatted string. So we have seen the F literal when we used our print statements. Very similarly, you can use a formatted string, and then you can put curly braces. Right now, this student has only two attributes, name and major. That's all he has or she has. So that's all we're going to print. So every piece of information about this student that we have, hey, we may also even include the class attribute if we choose to. And then we can say, hey, this is the class attribute, and we can simply, inside the class, we can use it with its name, college, or student.college. You can also use self.college, I'm pretty sure. So anyway, so str method, you can return any string here that'll tell you everything you need to know about that object at that given point of time. You can also print comsa, you can also print the file name and everything, and then use the return statement to return a formatted string. So all of these is one simple string. Okay, so now, okay, I have defined str, but how do I access it? So remember, public methods, you cannot call them from outside the class. So how do you do? Always create an object first. So now I've created student1 is an object, and of course it's giving me a red line because it needs name and major. So I give name John and major CINS for now. Okay, so I've created this brand new student. And then how do I access the str for this student? That can be by using print statement. That's it. At this point of time, if I run this code, it is going to print ULM, and the comma is coming from this formatted string commas here, ULM John CINS. I can even make it a nicer format, and I can say college. And instead of a comma, I can put a slash new line character, and I'm going to say name and then another slash new line character. And I'm going to say major. I can choose to print my object just like this. So anytime I use the print statement, it prints me nicely. So remember, whenever you printed a list, print in parentheses my list, it printed square brackets and a comma. Basically, what's happening is the str method for the list class is being called every time you print a list. So here, this is our own custom data type, and we're calling it a student. And then to this student, we can attach more behavior, okay? Students' attributes can be name, major, email, GPA, so on and so forth. But students' behavior can be, hey, he can enroll in a class, he can drop a class. So all of that we can tie inside this class as we go forward with this course. So how to do all of that, we're going to see that in the next lecture. Write our own user defined. So far, all we've seen is both the inbuilt methods in Python. Now, from next, we're going to see how to write our own methods and how to change our students' behavior. That's about all I want to cover here. This is the video for chapter 10, classes and object-oriented programming, and this is lecture number 2. Today we're going to see methods, so accessor methods and mutator methods. So let's pick up from where we left off last time. So the last time we defined a public class attribute, a protected class attribute, and then a private class attribute, and then we defined the init method, which bound the name and the major to the self attribute. And also we defined an str method, which returned a string, which pretty much helped us print the instance of this object, the state of the object as of that point. So if I printed student1, all the attributes that I have decided to return are being returned by str, and the print statement simply printed it for me. So that's all where we stopped. So these were the two built-in private methods in Python. Today, we are going to build our own custom methods. So basically, anytime you want to define a method in Python, you would use the def key and the function name and so on and so forth. But before we do that, I want to talk about the two different types of methods. So when we saw that original hierarchy chart, we saw that methods can be defined into one certain classification is private methods, protected methods, and public methods. The other classification was accessor methods and mutator methods. And we have seen what private methods are. You simply put underscores in front of it and you can make any method private. One underscore will make it protected and no underscores will make it a public method. So let's try to define what an accessor method is today. So let me go and find the accessor methods. So basically, these methods help us retrieve the data. So here, whatever we bound to the self, unless we print it, we don't know what the value is. But what if I wanted to know what is the name of the student? Then I can use a get method and say, get me the name of the student. We defined something very similar, or not defined. We have used one very similar to that in dictionaries. We've seen that in lists also. The get method. So when you pass the index or the key, it tried to get the value. So that's something very similar that we are about to do here. So these methods, they use the self parameter as the first parameter, and then they're simply going to return whatever attribute we ask for. So for example, I want to know what the student's name is outside the class. So basically, because both of these are defined as private attributes, from outside the class, if I try to print the student's name using the student object, Python is not going to be able to do that for us. So if we try to print it, it's going to say attribute not available for this object, simply because it's a private attribute. So now how can I print a student's name? So that's the so we can define a get method. So by coding convention, again, this is not mandatory, by coding convention, we try to use get as a prefix and say get underscore. What are we trying to get? Name. So more descriptive this way. And remember, every method has the very first parameter as self. Okay, that's the bare minimum for a get method, is the def keyword the get underscore, whatever you're trying to return, and the self inside parentheses and colon. Now we try to return what is the name at this point, because the name is now bound, the initializer method has bound this name to self dot underscore underscore name. So at any point in this class, now if I want name, if I want to use name, I'll have to use it with the self attribute. So there we go, very simply, two statements, and we've written our get statement. So how can I print the student's name outside the class? Very simply, using the student object, which is in this case, so this is where we have created our object. So student one is the object of student class. I don't like REPL anymore. The student class, and we've passed two parameters to it, two arguments to it, which are by the initializer method bound to self now. So if I try to print or get self name using the get name method, it should print me the name. So get underscore name is the only way I will allow a user to have access to the name attribute. No other way. You have to use the get method. So very simple. Oh, I'm sorry for that. So get name doesn't take any parameter. So I'll break it down in just 1 second. And then see, it printed, because I'm also printing students, so I'm going to suppress that, because that is the way to call the str method that we've done last lecture. So all I'm doing is getting the name, and I'm printing the name. Of course, I'm supposed to print it, otherwise it's not going to. So there you go, it printed the name as John. So I have successfully used the get name method that I've defined in the class. One thing to note here, that here we're not passing any parameters, but somehow when we defined the get name, we told to expect it one parameter. So how is that working? Because it did not work with our functions. If you entered a blank parentheses here, it had to be blank here too. If you entered something here during the function call, then you have to pass something here. So why is this happening? Well, very simply, in the background, this student one is being passed inside this parameter, and that is self. So any object that you create, so if you created student one, that is going to be passed inside that, and self becomes student two at that point. So that's how it works in the background. So if you have one parameter, which is self, we don't have to use any parameters to call get name. So can I create another get method? Well, actually, I may have given it as a try me for you to do here. So how to call private accessor method protected. Okay, so this is a public, because we know that without underscores, it's a public method. So if I use underscore, that becomes a protected method. And how to access it? Very simply, put the same underscore and run it. It'll still print the name for you. And if you want to make this method private, for whatever reason, if you want to make it private, now that means you have hidden it from outside the class. You cannot access that method from outside the class. If you try to run it, it will say it has no attribute get name. So we have successfully hidden it. One thing I want you to notice is from its definition, it looks like get name accepts one argument. So when you look at the definition, get name is accepting one parameter, but here when we're calling it, we're not passing it. Basically, the student one becomes that parameter for it by definition. So we've defined the public, protector, private. So that's all about accessor methods here. Going to see what mutator methods are. So get methods let us access those attributes like name or major, but how can I change it? If I wanted to change the name of a student, well, really there's no way, just the way the class is defined at this point, that I can make that change. So if I want to change the value of any attribute, then I would have to define what's called a mutator method, or we also call it set method. So how can you define a mutator method? Coding convention encourages to define mutator methods with the prefix set. So just the way that we call this get, the mutator methods are going to be set. So let's go ahead, define our first mutator method. So def and set underscore name. So what I'm trying to say is, hey, I have the original name, but I want to change it to something else. So for example. That's what I'm going to do. So set name is accepting a new name. So what is going to be the user will have to tell you, okay, I want to change this name and I want to change it to what? So we have to get that new name from the user. So, and then we change our existing, because our name is now stored in self dot underscore underscore name. So very simply, whatever the user gave me using the new name parameter, I am going to set the name to that. And I'm not going to return anything. That's the one statement that I need to do, and name is going to change. So having defined that, I'm going to change this back. So for the scope of this class, we're going to keep all our get and set methods as public methods. We're not going to be using protected or private. But so now that I've defined a set method, how do I call it? So I'm going to delete that. Okay, so I have nothing else. I have created the object, and I'm going to change the name to Mia. Just I'm bored with that name. All right, so student one is, I'm creating a student called Mia with history as a major. And then as soon as I create this object, init is going to get called. So now Mia is going to be stored in name, and history is going to be stored in this variable. And then these two values, I'm attaching it to self using this notation. So self dot, and I'm making these private attributes. So I don't want these attributes to be accessed from outside the class. So think of this as when you're trying to borrow a book from a library, right? So you have to follow particular books are not just on the shelf for you to go get whatever you want. Of course, all books are free when you're borrowing it from a library. You're not buying them, but you have to follow through the check-in and the checkout process that the library has in place for you. That's pretty much what we're doing when we define a class. Hey, you can access whatever you want and you can modify whatever you want, but you have to follow or use the methods that I have defined to go through that process. So we can write get name for every single attribute here, get name, get major, whatever the attributes the student has, we can write each of them a get method, but we are going to decide what we're going to allow them to get and what we're going to allow them to set. So that's where the programmer has the control. So if I don't, for whatever reason, don't want them to change the major, then I'm not going to write a get underscore major method at all. So anyway, or a set underscore method, major method at all. So, all right, without further ado, so now I've created Mia. So student one is my object. So to be able to call any method, we have to use the object's name. And then here I'm going to say set underscore name. And then here, while this looks like it's accepting two parameters, we do now understand that this student is going to be the first parameter. So we don't have to pass self anymore. We just have to provide, okay, what is the new name? Okay, so I'm changing the name to Mira. And now how can I print? How do I know that this name has actually been updated? Well, simply, I'm going to say print. Well, instead of print, I'm going to say name. Now is going to be student one. We've seen how to get the value of something. We simply use get name, and then I will print this name. Okay. I don't know why Rebel keeps adding more information there. So simply I created the object and I called the set method and changed the name to Mira, and then using the get method, I'm getting the name. So at this point, this name, if set name is working correctly, this name should have the value Mira from the get name, because get name is simply returning self.name, and then I'm trying to print that name variable. So there you go. It's not Mia anymore. So if I do the same thing before and after, if I get name, so when the object is created, the name was Mia, and after the set method has been called, her name became Mira. So let's just say I have another attribute. I'm just going to leave the object name as is, and I say, hey, I want to also do GPA. Okay, instead of simply major, how do I pass a GPA? I'm going to send it in the third parameter. So I have the red line because the init method needs to accept that. So I'm going to say GPA, and then self dot, if I say I want you to define GPA as a private attribute, then I want to see 2 underscores. And for the scope of this class, all of our attributes are going to be private. And next chapter, we might see some protected and private, but mostly we're not going to see any public attributes. Every single one of them is going to be either protected or private. So anyway, without further ado, so I'm going to write a get name. So why can't I write a get name for GPA? So I'm going to call it get GPA. I don't have to pass it anything other than the mandatory self. And I'm simply going to say return self underscore underscore GPA, because that is the GPA. That is where the GPA from the user coming from the initializer is being stored. So basically look at the workflow. The object is created, the class is called, and as soon as the class is or the object is created, it triggers init method. So init takes all these parameters, all these 3 parameters, name, major, GPA, and it binds it to the self. And then self is passed on to every single method. So this is very similar to our lists or dictionaries that we've seen. We've passed our list or dictionary to every single function, add student or lookup student, because everybody needed to know what's the content of that dictionary or list was. So very similarly, self is an object that is being passed around to every single method in this class. So now, if I do print student 1, it's not going to print the GPA because why? I haven't defined it. So it's only printing me college, name, and major. So how do I make it print GPA? Very simply, I'll go to the str method and I'm going to put, hey, now I have another parameter that defines the student. Please add that as well in the str return statement. So I'm going to put GPA and I'm going to put this variable as GPA, and there we go. That's all there to it. So now if I try to print it, it'll print me the GPA. That's all fine and dandy. How do I access just the GPA? I don't want to print the whole student. Don't give me the whole book. Just give me one chapter. I just need the name. I will simply say print student1 dot get underscore GPA. And that's it. And it's going to print the GPA for me as 3.5. And similarly, so on and so forth, we can write the set method and say def set GPA self, and then it needs a new GPA because we're modifying. We need to know what name are we, what value are we modifying it to. So self underscore underscore GPA is going to be this new GPA, whatever the user has passed. So there we go. Now we're going to use the set method using the student1 dot set GPA. It's not 3.5 anymore. I want to set it to 3.76. And if I print it, how do I access the GPA? Simply using the get method, I'm going to get the GPA and then print it and say, here we go. It was 3.5 before, but the set method has changed it to 3.76, so on and so forth. So if I create another student, say, and call it student 2, and wow, well, REPL kind of gave me some automatic values, and I don't know how it did that, but that's pretty cool. So now I'm going to print student 2, and then I'm going to get the GPA. All right, so for student 2, let's see if I get the GPA, it's supposed to print 3.2 for me. Why? Because student 2 now is the new self. So anywhere I have self.gpa, it refers to the student 2 object. Basically, whatever object that we are passing is the one that gets passed to this function. So because student 2 is getting passed and student 2 has all these values bound to self, when you try to get the GPA, it is going to print the student 2 value. Same thing, you can set the GPA for this student 2, everything that you could do with student 1, you could do. So if I try to say print student 1 dot get major, open close parentheses, because it's a function. If I run it, it's not going to do it because there's no get method for major. Okay, how about major? Can you please give me major because I need to know what it is? from outside the class, there's no way because major is hidden. That's the whole point of object-oriented programming is we want to have control on what the user can or cannot do or have access to using our class definition. So that's pretty much accessor methods and mutator methods. So as many attributes you would pass here, it would be nice if you could write that many get methods and that many set methods. So one object that we've created. So student 1 at this point is one object, and we have created student 2 also. And then Amy and accounting and 3.24, let's say that. So I've created 2 objects, right? So remember when I said lists and or dictionaries can save any type of data types. And that is also including lists. So if I have a student, so in this case, I have this. So let me just use that code, comment that out and say, I have a student, Mira, computer science, history. And the reason why I'm having this issue here is because I'm supposed to pass another one because of defined GPA. So 3.4, and here I'm going to say 2.67. So I've created 2 students. So now I can create a list with those 2 students and call it an object list. And then how to create a list using square brackets, and each element is separated by a comma. So in this case, each element is nothing but an object. So when I try to print this object list, it's going to tell me that it is 2 objects. So it looks kind of weird here, but what it tells you is there's one object at that memory address and there's another object at that memory address. So basically it's a list of objects. Well, right now this is not very informative to me right now, but how can I go over a list of elements and print the elements? Well, simply element in object list, I'm going to print, instead of object list, I'm going to print each element. So guess what is going to happen when you do that? Now each of this will now contain each of the objects of this. So anytime you try to print an object, it is going to trigger the str method, and then it is going to print both of these students' data in this particular format that I've defined. So when I try to run it now, there you go, it is going to print the first student, and then it's going to go over again in the for loop and print the details for the next student coming from the str method. So very similarly, instead of list, I can also create a dictionary of objects. So instead of calling this student 0 and student 1, because that is what's happening here, this is 0, student at 0 index position. This is student at 1 index position. What if I wanted to create a dictionary and store the key, the CWID as the key? So that is how I would do that. To delete these old student definitions because I've added a GPA now. So there we go. I have to make that into a curly brace, not a square bracket. So instead of creating a list, I'm going to give a key value pair. The key happens to be the CWID for student 1. This happens to be the CWID for student 2. So again, if we try to run it now, it is simply going to display the key and the value is an object. So anytime you see something like this being printed, do understand that you are printing an object. You are trying to print an object. Okay. So again, the best way to print it is for each element in object dictionary, print, instead of object dictionary, I'm going to print each element. Each element. And when you print it now, the str method gets called, or actually each element. So remember, when we use a for loop over a dictionary, it doesn't print the values, it will print the elements. So if I want to print the keys, so if I want to print the value at that particular key, I would say object underscore dictionary, and then give the key inside square brackets. So first it's going to print object dictionary at 310, which happens to be this. Because it's in a print statement, it is going to trigger the str, so on and so forth. So there you go, it printed both the students. So we can also have list of objects and dictionaries of objects. So we're going to learn how to do one object first, and then we're going to see how we can build on to create a list or a dictionary of objects. So that pretty much concludes this chapter, chapter number 10, classes in object-oriented programming.